We will now compute historical value at risk, which is the most direct and assumption-free way to estimate VaR. The core idea is simple. Instead of fitting a model, we use the empirical distribution of observed returns. We start by defining two confidence levels, 95% and 99%. These correspond to different points in the left tail of the return distribution and are commonly used in practice. A higher confidence level means we are looking further into the tail, focusing on rarer but more severe losses. Historical VaR is computed as a percentile of the return series. For a 95% VaR, we take the 5th percentile of returns. And for a 99% VaR, we take the 1st percentile. In code, this is implemented using NumPy's percentile function applied directly to the return array, as you see here. This approach makes no distributional assumptions. It relies entirely on what has actually happened in the data. The output table shows the resulting VaR estimates in return space. For example, a historical 95% VaR of approximately minus 1.6% means that, based on historical data, losses worse than this occurred on about 5% of days. At the 99% level, the threshold is more extreme, reflecting rarer downside events. These values are negative by construction because we are explicitly looking at losses here. In practice, VaR is, as said, almost always communicated in monetary terms. Once we have a VaR return threshold, we multiply it by portfolio value to obtain a loss estimate in currency units, euro, US dollar, whatsoever, wherever you are based. This step is straightforward, but it's critical for making risk measures interpretable and actionable. The main strength of historical VaR is transparency. It's easy to compute, easy to explain, and directly tied to observed market behavior. There are no hidden assumptions about normality or volatility dynamics. At the same time, historical VaR has clear limitations. It assumes that the future will resemble the past. It cannot account for events that have not yet occurred, and it can underestimate risk when market conditions change. Historical VaR is also sensitive to the sample period. Different time windows can lead to very different estimates. Because of these limitations, historical VaR is often complemented with model-based approaches. So in the next section, we'll compute parametric value at risk under a normal distribution assumption and compare the results.